Hey guys, today we're going to talk about acids and bases, and specifically we're going to focus on two main things. What pH means is the first thing, and the second thing is how to tell what the pH is using an indicator. So, let's get right to it. Before we jump right into talking about pH though, I just wanted to point out for you that on your reference table, table K, there's a list of common acids. So if you see an acid and you're not sure what the technical name for it is, your reference table has the names of acids listed. Likewise, it has table L for common bases and the names of the bases listed. And usually, there are other bases also. These are just the common ones. But maybe you'll have a different metal, but still have hydroxide in it. So you can always just use this to help you figure out a name if you're not sure how to name it. Yeah. So we're going to be looking at table M in just a minute. But before we know how to use indicators, we need to understand what pH means. So on the screen I have the pH scale, and you can see there's a whole bunch of different things that are being shown. So if you have a lemon, you're on the acidic side, or your stomach acid is acidic. And if you're on the basic side, that's like drain cleaner, bleach, soap. Notice how at the bottom it doesn't say basic, it says alkaline. Alkaline is another word for saying basic, so I'm just going to write basic down there. And of course, in the middle between acidic and basic, we have neutral. So water without adding ions and stuff is supposed to be a pH of 7. Yeah. So let's get into what it means to be a pH of 8. Let's go basic for a second. I'm feeling basic. So if you go from a pH of 7 to a pH of 8, all that means is that you've added hydroxide ions, the base ions. Remember, according to Arrhenius' definition, base ions are OH minus and acid ions are H plus. So going from a pH of 7 to 8, you've added 10 times the amount of base ions. Going from a pH of 8 to 9, every single pH unit you move, you multiply the number of base ions by 10. So that goes for all of them. So you just keep adding more and more hydroxide ions the further basic you get. Likewise, if you are going acidic, and I'll change colors for this, oops. If you're going acidic, every pH you move, you are adding 10 times the amount of H plus ions instead of base ions. And here again, from a pH of 6 to a pH of 5, you will have added 10 times the amount of H plus ions. So it's all a matter of which ions you have present in your solution and how many of them there are. If you look at, let's say, a pH of 7 compared to a pH of 5, so going from 7 to 6, you added 10 times the amount of H plus, and 6 to 5, again, you added 10 times. But let's say you wanted to go directly from 7 to 5. You would actually be adding 100 times the amount of H plus ions. It works the same way on the base side. If you went from a pH of 7 to 9, you would be adding 100 times the amount of base ions instead, hydroxide ions. If you'll recall from our class the other day, even if you are a pH of 9, you're on the basic side, that doesn't mean you don't have any acid ions. You still have some acid ions in solution. The key thing is that you just have a lot of base ions. And same thing if you are on the acidic side. It means you have more acid ions, a lot more than you have base ions. And when you're at pH of 7, you're going to have both ions in solution as well as just normal water. The key thing that I want you guys to know is that when you are neutral, you have the same amount, I'm going to put like a big equal sign, the same amount of H plus as OH minus ions. And the further you go basic, you're going to have more OH minus ions, and the further you go acidic, you're going to have more H plus ions. Okay? So at this point, we've probably already talked about indicators and how to use them, but I'm just going to walk through again what the idea is behind them. So let's say you decide to use methyl orange to figure out about the pH of your solution, and you put methyl orange in a highly basic solution. Now methyl orange has a color change that's between 3.1 and 4.4. So on our pH scale, that is acidic because it's under a pH of 7. And if you have a very basic solution, you're going to be above a pH of 7. So that means like on the scale, you're all the way over here. Oops. You are over here. Like let's say this is our, you are going to be on the right side of a pH of 7. So you're all the way on the basic side, whereas a pH of 4.4 is on the acidic side. So if you're all the way over here, the solution is going to look yellow. If you have a different solution that you're testing, and let's say it's lemon juice has a pH of around 2, you're going to be on this side, you're going to be way more acidic than 3.1, so in that case, your solution will be red. So the way that you use an indicator is that you have to be outside of this range. If you're between 3.1 and 4.4, you're going to be a mix of red and yellow. I mean, that could indicate to you that you are between that range, but usually people use indicators for when you are on either end of the spectrum. So it would be helpful if you had a solution of a pH of about 3, you would know it's red. And then as soon as you're turning 3.1, it's starting to get a little more yellow until you get to 4.4, and then it's purely yellow. And beyond 4.4, it's all going to be yellow. Alright, let's look at bromothymol blue. So it changes color between a pH of 6 and 7.6. So if it is under 6, if you have a solution below a pH of 6, it's going to be yellow. If you have a pH of a solution above 7.6, it's going to be blue. It is between, if you're between the two, it's going to be a mess of yellow and blue and hard to read. So the key thing is you use the indicator mostly for solutions that are below the pH or above the pH, because that way it's clear to you whether you're on the more acidic or more basic side. For phenolphthalein, this is the indicator that we use for the titration of my unknown acid. It was colorless up until we had a pH of 8. So it was colorless. It was colorless before your pH of 8, and then as soon as it started turning pink, that was when it was between 8 and 9, and when it's purely pink, we have gone too far, and it is above a pH of 9. So just to break it down, the color that it is, if it's purely red, it's going to be under whatever pH is on the left side. If it's purely the other color, it's above the pH on the other side. Alright, we're going to do some practice problems with this and see how it goes. So for the first question, it says, what is a substance that is one color in an acid and another color in a base? If it's changing color based on the acidity or basicity, that means that it is an indicator, because it is indicating to you about what the pH is. What color does litmus paper turn in the presence of an acid? So if we go back to our table M, our indicator table, it asks about what color litmus paper is in presence of an acid. So here, the litmus paper would be useful for us if it's below a pH of 4.5. So in an acidic solution, it's going to be red. So for this one, red. What color does litmus paper turn in the presence of a base? So if you are looking to use litmus paper, it has to be above 8.3. And then what color will it be? It will be blue. What color does phenolphthalein turn in the presence of an acid? So phenolphthalein, if it's on the more acidic side, it's going to be under a pH of 7 or under a pH of 8. I know you might say, well, Miss West, what if it's 7.5? Then isn't it still basic? Yes, but if you have an acid, then it'll be 6.5. It's still going to be colorless. So under a pH of 7 or 8, it's going to be colorless. What color does phenolphthalein turn in the presence of a base? So of course the base has to be above a pH of 9 for it to be totally pink, but it is pink for more basic solutions, so pink. We are going to skip number 6 because number 6 has to do with strong versus weak acids, which we are not going to focus on in Regents chemistry. What color is brymothiol blue in an acidic solution? So brymothiol blue is here. If it's acidic, then it's going to be on the lower end, so it will be yellow. Oops. So yellow. Number 8, a solution turns blue with bromocresol green and yellow with bromothymol blue. What is the pH range? Ooh, this is a fun problem. So we have 2 that we have to pay attention to. Alright, so if it's blue and bromocresol green, well, let's find what that limits us to. So if it's blue, here, it has to be above a pH of 5.4. Okay. And then the second part of the problem said, said yellow with bromothymol blue. Alright, now we have to find bromothymol blue. So if it's yellow, then it's under a pH of 6. So we have under a pH of 6 and over a pH of 5.4. That means that we are going to be between like 5.5 and 5.9. So notice how you can use like 2 different indicators to really like hone in on what the pH is. Kind of like some fun problem solving. So we said 5.5 to 5.9, I think. Yep. A solution turns yellow with thymol blue and blue with bromothymol blue. Alright, let's first find yellow with thymol blue. What is that? So, let's see, thymol blue is here. So if it's yellow, it's under a pH of 8. I'm just gonna go like that. Yellow. And for the second part, it said, and we are blue with bromothymol blue. Okay, so if we're blue in bromothymol blue, that means we're above a pH of 7.6. So between 7.6 and 8 is like